The P2 strategies are actually the same principles that the life cycle assessment would utilize. This is just more modified and more applicable in such a way that it applies the cradle-to-grave approach. Sometimes in industry, this is also called womb to tomb. That means, as I have mentioned, if you have this product, you are not just considering how you would dispose this after it has ended its life. Your main concern would be how much of these raw materials will be utilized and what kind of raw materials are you going to utilize in the manufacturing process. So that gives emphasis to cradle-to-grave approach or the womb-to-tomb approach. This is actually widely used methodology already for systems engineering design, and it focuses on quantifying environmental burdens. Although in this particular course, we will just use a superficial life cycle assessment. That is, we will emphasize the qualitative approach, but not the quantifying approach. The quantification, that is the computation of the actual impact, would be taken into consideration in another course. This is actually another big course that needs our attention. Now, what are the components of life cycle assessment? We have inventory analysis, we have the impact analysis, and then we have the improvement analysis, which we will discuss later one by one. Before you proceed with the three components of life cycle assessment, one important thing that you have to identify is the systems boundary. So this figure shows you how to identify the life cycle system and boundaries. As you notice, these processes are actually involved from the manufacturing process up to the usage of the product, up to its recycling, and until you finally dispose the product. And as you notice, as you apply the first component of LCA, which is the inventory analysis, you have to identify for each functional unit the inputs. And what are the inputs that we have to consider? We have to consider the raw materials, which would include one of the most important resources, water, and of course, the energy resources. Now, you also have to do inventory analysis of the outputs. Definitely, one of your outputs being a manufacturing process is to identify the product. But of course, since there's no such thing as 100% efficient process, most of it would be waste. But of course, we want to minimize the waste generation. Still, these waste that will be produced would be having impact. That would give you the next component of the LCA, which is after identifying the waste being generated into different matrices of the environment, you can identify already the impacts to these environmental matrices. So, in inventory analysis for the first part of LCA, you consider the impact on water quality parameters. Then, you also identify the different pollutants that will be emitted, not only from the burning of the energy, but also for each process. That would give you an idea how would you apply your chemical engineering unit operations and processes in identifying the air emissions as well as the water effluents and characterization whether the solid waste would be hazardous or not. Some of the key features of LCA include the following. You have the macro system level or cradle-to-grave analysis. This would give you, after your assessment, an overview of the entire, for example, in your case, entire manufacturing plant. And then, before you do this analysis, you have to consider the normalization or functional unit basis. What would be the functional unit? This would refer to the different processes that would comprise the entire plant. And then, you also have this key feature, which is the multi-criterion perspective. This is the beauty of LCA. You can identify what would be your purpose. I have reiterated in the first part that environmental degradation would be two components. One would be generation of waste, but to complete the picture, that is also the utilization of resources. So if you would like to have a life cycle assessment only for the utilization of resources, let's say identifying which part of the manufacturing plant would have the highest consumption of water, or let's say in a power plant, you would like to identify the area or the process with the highest energy consumption, you can do that in LCA. But of course, the complete life cycle assessment would involve all impacts generated from the industrial plant, such as the consumption of resources, as well as the specific waste and specific emissions that would be coming from the entire process. Now, ISO 14000 gives you the different components of LCA. So if you're interested in knowing the details of these important components of LCA, you can make use of the ISO 14000 document. So specifically, I have given here ISO 14041 would give you details on goal and scope definition. ISO 14041 would give you the inventory analysis, and then ISO 14044 would give you the impact assessment, and then finally for ISO 14043